Okay, so we're back and looking at drawing Lewis structures, which is one of the major parts of this chapter. So this is kind of the guidelines, but again, once we do them, it makes a lot more sense. So the first thing you do is you kind of pick out how you think the molecule is going to look. It's typically that the central atom is the least electronegative, which is typically the one out front, except for hydrogen. What you're going to do is you're going to calculate the number of shared electrons, and you do that by figuring out how many you need and how many you actually have available. Third, you actually place the electrons, so any shared electrons means bonds, so you draw those in. And then fourth, you make sure that everyone gets octets. Now the only thing you may want to write down here is remember that hydrogen only gets 2 electrons, because remember that's all he can handle. Helium doesn't really matter because he doesn't form bonds. So we'll start off pretty easy. First one we're going to do is just chlorine. So when you do need, so the N equals need, and you don't have to write that down if you don't want to. But that means, like, in a perfect world, how much would they need? So in a perfect world, we have 2 chlorines, and they would each want 8 electrons. They would each want their own octet. So I would do 2 times 8, and in a perfect world, I need 16 electrons. Available are your valence. So you have to look that up on the periodic table, and this is just normal chlorine. So each chlorine has 7, so we do 2 times 7, and we have 14 available electrons. And then for sharing, you just subtract the 2. So you do need minus available, and what we do, we have 16 minus 14. That gives us 2 electrons. And remember, for a bond to form, you need 2 electrons. So what that means is that there will be 1 bond formed. So then what you do is, once you know how many bonds you have, you're going to draw in the bond first, but you have to make sure, and you may want to make sure, remind yourself, here, let me move that because it's annoying. Make sure you use all available electrons for everyone. So when we're done, we need to go back and make sure that these 14 electrons that we started with are on the actual drawing. If they're not, it means we missed something. Oh, and the only other thing you want to make sure all elements have access to 8 electrons except hydrogen. So when you go to draw it, all that 2 chlorines can do really is stick together. So what we're going to do is we're going to draw 1 chlorine, draw our bond, draw our other chlorine. Now what we just did is we just did that sharing. So this line right here is indicating that we're sharing 2 electrons. So now we need to make sure they have access to 8 total. So each chlorine has access to these 2 already. So now we need to draw 6 more for this chlorine. So 1, 2, 3, 4, 5, and 6. So we just draw those as dots because they're not bonded. So we have 1, 2, 3, 4, 5, 6 plus the 2 in the middle. He has 8, and then we're going to do the same thing for the other guy. And then what you want to do is just check. Did you use all of your available? Did you use that 14? So count them all up, and if you count them up, you have 14, which means you did it correctly. And then just a couple things here. This one is called, what this is called the complete Lewis. Oh, that's bad writing. You can also, I'm going to do it up here, draw one where you leave out the lone pairs, and you don't normally do this, but just so if you see it, this is called structural. And if you look at this, we have 1 shared pair, and we have 6 lone pairs, or you could say non-bonding. So just some different things you might see with the Lewis structures. Alright, so our next one is the perchlorate ion. And we'll do the same exact steps. You always do the same steps. So the first thing we say is we need to do our need. So we have 5 elements, 1 chlorine, 4 oxygens, and in a perfect world they would each like 8. So they would need 40 electrons. Available, you have to look up at our periodic table. Chlorine gives us 7, and each of the oxygens give us 6. And then you have to be careful because this -1 means we have an extra electron. So we add 1 extra, and that gives us 32. And you may want to note that -1 means extra electron, just so when you're looking back at your notes it makes sense. And then we do our shared, and that is our 40 minus our 32, and that will give us 8 electrons shared, or 4 bonds. So when we draw this, we have to have 4 bonds between them, and we're going to have to make sure that we use all 32 of our available. And then one thing you would see here is, remember, chlorine's out front, so that's giving us the hint that most likely this chlorine's in the middle, and that means the oxygens are probably surrounding it. So just that's a hint you might see. So we have our chlorine, and we're assuming that probably all the oxygens just go right off of him. So we're going to draw our oxygens. And then what we need to do is add in our extra things. So again, we have to give them access to 8 electrons. So if we look here, this oxygen now has 6 here and 2 in the bond. If you look at the chlorine, he already has 8 because he has access to all the bonds. So he has access to each of the bonds here, which is already 8. But our little oxygen guys do not. So that's where we're giving them. And then because this is a -1, you need to indicate that. So you actually, ooh, I just took out one of my dots. I'll have to add it back in. There should be a dot there. You actually have to indicate that. So you actually draw your brackets, and you actually say, hey, this is -1. So that's your complete Lewis structure. And again, we can write that down here if you want. This is complete. If you just want a structural, then let me just draw this first. Make my life a little easier, I think. Just to have your -1, and then you'd only really worry about the bonds. And what the structure will be for is later when we're looking at the shape. And again, it's not that the other lone pairs aren't important, it's just that that's not really what we're looking at for structural. And then just so you have it, you may want to remember there are 4 bonding pairs, and there are, if you count them up, 12 non-bonding or lone pairs. And again, count all your electrons and they should equal 32, and they do. Last one we'll do for this section is carbon dioxide. And again, same thing, our need, available, share. So our need, we have 3 elements that are very normal, they're not hydrogen or anything. So we need 3 times 8, which is 24 electrons. Again, our available has to do with our valence electrons. So carbon gives us 4, each oxygen gives us 6, and that gives us a grand total of 16 electrons that we have. And if we do our share, 24 minus 16 equals 8 electrons, or 4 bonds. Now this one's a little tricky because if you think about this, we don't have that many things. We don't have that many things to attach. So when you have more than you really need to attach things, this is going to indicate, I'll write that down, more bonds than is normally necessary means multiple bonds. So I'm going to show you the most likely one, and then eventually we'll talk about formal charge and stuff. But for right now, the most likely thing again is we have carbon, so the carbon will be in the middle. And the most likely thing is our oxygens are on either side. Most things go with symmetry, not always. Now we need to attach these. So we put one bond here and one bond here, and that's only 2 of our bonds. We indicated we needed 4. Now theoretically you could give one side a triple and one side a single, but again, that's not very likely, and eventually, like I said, we'll talk about formal charge and it doesn't work out. So you usually try and do things that are even. So what we end up doing to give these guys 4 bonds is we give 2 between each one. So that gives the carbon in the middle, he's already good. He has his 4 bonds or 8 electrons. But if you look out here on our oxygens, they only have access to 4. So that means we need to give them a couple more electrons. And that should be your Lewis structure for carbon dioxide. And again, this one is called our complete. Well, that's really nice today. And our structural is just the carbon with the double bonds. And then if we look up here again, just so you have it, that means we have 4 bonding pairs and 4 non-bonding / lone pairs. So that's kind of just how you do Lewis structures. You're going to be practicing these a lot. They're like a major part of this chapter. So you really want to make sure you have to do the neat available share. If you don't, you will not be able to predict multiple bonds, or in a little bit we're going to have less bonds. So just make sure you're really paying attention.